Jai Hind everyone, myself Sandeep Yadav, Assistant Professor CSC Department in Ajay Kumar Garg Engineering College. Today I am going to deliver a lecture on concurrency control in the subject DBMS. Most of us are aware of what is concurrency. Concurrency is nothing just a mechanism whereby several of the transactions are running parallelly to each other. Why we need concurrency? Concurrency is necessary to increase the CPU utilization, to decrease the waiting time, and to efficiently utilize the DBMS. Following is the outline of the topic that we are going to discuss today. First, what is concurrency? Second, lost update problem. Third, dirty read. Fourth, locking. Fifth, timestamping protocol, and last one is deadlock. Now first we will be studying what is concurrency. So concurrency is the ability of database to allow multiple, that is more than one users to access the data at same time. Now due to concurrency, three main types of problem occurs. Number one, lost update problem. Number two, dirty read. Number three, incorrect retrieval problem. See, as a result of concurrency, there is a competition between several of the transactions, and as a result of that several problem occurs. So we need to find what these problems are and how to tackle these problems. So we will be discussing these problems one by one. Now first we will be studying dirty read, lost update problem. This problem indicates that if two transactions T1 and T2 both read the same data item and update it, then the effect of the first update will be overwritten by the second update. Let us consider this example. There are two transactions. Initial value of x is 100. There are two transactions T1 and T2. So first instruction executed is read x. Thereafter read x by transaction T2. Thereafter we update the value of x. Now the updated value of x is 75. Next, the update is being applied by transaction T2. Now the value of is 50. That is, the value has been overwritten by the second update. Now how to avoid this problem? Here the transaction T2 must not update the data item x until transaction T1 has committed the data item. See, the problem is the value is being updated here, thereafter it has updated this value. So but we are not able to commit this value. Until unless we commit this value, we should not apply the update for this operation. Only then we can resolve this problem. So this problem can be resolved only and only if we update the value of T2 only when transaction T1 has committed the value, so that the various type of losses that we suffer are not affecting the transactions. Now second problem is dirty read problem. Now dirty read problem arises when one transaction updates some data item and then fails due to certain reasons. This updated data item is retrieved by another transaction before it is being changed to original value. Let us consider one example. Here the initial value of a of x is 100. Here the initial value of x is 100. Now there are two transactions T1 and T2. So we have updated the value of x. Now updated value of x is 50. Thereafter transaction T1 read that value, but due to certain reason the transaction T2 rollbacks. So whatever value the transaction T1 has read is dirty value. Since transaction T2 has rollback, so the value of x that is being read by transaction T1, the value that it has read is 50. But since the transaction has failed, so it has read 50, but since the transaction has failed, the value must be rolled back and T1 must read the value 100, but it has read this value 50. So this problem need to be tackled. Now how to avoid this problem? The transaction T1 must read the data item, must not read the data item until transaction T2 can commit that data item. See, the problem is, the way to avoid this problem is that this transaction T2, whatever value this write, first it must commit this value, right? Then transaction T1 can read this value, otherwise it will not be possible for us to avoid this problem. So first T2 will commit the value, thereafter transaction T1 can read this value. If transaction T1 read the value that transaction T2 has not committed, then we will be facing the problem of dirty read. Now we will be discussing certain techniques to deal with concurrency. First technique is locking. So locking is a variable associated with data item to control access of the data item. Most of us are aware with the concept of lock, the lock that we use in our home, and similar analogy we are using here. So locking is a mechanism whereby we control the access to the data item. It is sort of a security mechanism. See, locking variable, this is diagram showing multiple users accessing the data item. First lock variable, then another is also using. Now another user want to access the data item, it will not be able to access. This is clearly demonstrate here that if second user also want to use that particular data item, it will not be able to access this because one user is already accessing that data item. Now based on locking, there is locking based protocol. Data item can be locked into two modes. One is shared mode, another is exclusive mode. Shared lock is that we can only read the value, we cannot write any value. That is shared mode. That is, if transaction T1 want to read a particular value, it can read a value, and if another transaction T2 also want to read that value, it can also read that value at same moment of time. So for only read operation we will be using shared lock, that is denoted by S. Now second type of locking is exclusive lock, whereby we can read as well as write the data item, that is being denoted by X. Now what is this data item that we are talking all about? A data item can be a single field, it can be a file, it can be record, it can be page, or it can be entire database. So the size of database can be fine or it can be coarse. If we have the larger number of data item as a larger size, then we will be facing overhead, and if we have the smaller data item size, then we will be having more number of locks. So we need to keep in mind while deciding the size of data item. Now lock compatibility matrix. Suppose in this matrix we show the combination as when we have applied locking on one transaction, will another transaction be able to apply lock or not? So for that purpose we have a two-dimensional matrix. Here we have two transition T1 and T2. Suppose transaction T1 has applied shared lock on a data item X, and T2 also want to apply the shared lock on that data item. Will it be able to apply or will it not be able to apply? See, in shared lock a data item is only reading the value. So if transaction T1 is reading a value and another transaction T2 also want to read this value, then we can allow this operation. So this value will be yes or true or compatible. Since reading the values does not change the value, so this operation can be permitted. Now if transaction T1 has applied the exclusive lock and another transaction T2 also want to apply the shared lock, should we allow this operation or shouldn't we allow this operation? See, whenever whenever a exclusive lock is applied, means the value is being changed, the value is in being transition. So, if another transition want to read that value, we cannot permit this operation because that will lead to conflicts and cause inconsistency of database. So, this operation is also not permitted. Next, if the lock applied is shared lock and another transition T2 want to apply the exclusive lock, so we should not allow this because a transition is already reading this value, and if another transition want to update that value, then the transition that is reading the value may change. So, original transition may not be able to read the proper value, again it will be leading to the conflict. So, we cannot allow this mode also, therefore, this value is also no, that is not compatible, or we can say false. Now, the last one, suppose exclusive lock is being held and another transition also want to have exclusive lock, then we cannot permit that lock because that will again lead to conflicts. So, in a nutshell, we can say that if a shared lock is being allowed, then the only other type of lock that can be applied on that data item is shared lock. Only read operation does not result in any conflict. If any one of the operation is right operation, there is bound to be conflicts. So, all other modes of locking will not be compatible, only shared lock locking will be compatible. Now, how the locking is being done? Suppose a transition want to apply a lock on data item X. First, it will send its request to the lock manager. There is a lock manager in DBMS. The purpose of lock manager is to grant the request based on the locking matrix as well as whether the data item is free or not, or any other request is there before that particular transition. So, all these things will be decided by lock manager. So, whenever transition want to apply the lock, it will send its request to lock manager. Lock manager will grant the request based on the fact that it is not in violation with locking matrix or any other of transitions is having request for it or not. The request will be proceeding in FIFO order and as well as depending on the lock compatibility matrix. So, a transition may grant a lock on data item if the requested mode is compatible with the already held lock by another transactions. If the lock cannot be granted, then the requesting transaction is made to wait till all the incompatible locks held by the transactions have been released. If a request has been made for a lock, for a exclusive lock, and that data item is not free, it has been held in incompatible mode, then the other transaction has to wait till the lock has been released. Any number of locks transactions can hold shared lock on any data item, but if a transaction has a exclusive lock on the data item, no transaction can hold any lock on the data item. Now, locking based protocol. This protocol divides the transaction execution into three parts. First, when the transaction start executing, it create a list of data item on which they need locks and request the system for lock it needs, that is lock acquisition. When the transaction require all the locks and no other locks is required, the transaction keeps executing its operation. Now, the third, as soon as the transaction release its first lock, the third phase is start. In this phase, a transaction cannot demand for any lock, but it only releases the acquired lock. See, whole of this process is being shown using this diagram. Here we have the lock acquisition phase, whereby we request for the locks, and after the locks are acquired, we will start the transaction execution. After the completion of transaction execution, we will be releasing the locks sequentially. that is in the lock releasing phase, that is phase third. Now when we are starting releasing the lock, we will be no longer acquiring the other locking. Now two phase locking, this protocol works in two phases. First phase is growing phase and second phase is shrinking phase. Now first phase, growing phase, in this phase a transition obtain locks, but it cannot release any lock. That is, only locking is permitted, unlocking is not permitted, and this phase usually occur in the beginning of the transition. When a transition takes the final lock, then it is called a lock point. So when the final lock has been taken, then that point is known as lock point. Second phase is shrinking phase. In shrinking phase, the locks are released but not acquired. That is, this phase starts at the end of the transition. When all of the task has been performed, then we will be releasing the locks. That is, in the shrinking phase, the locks will be released, but no new locks will be arrived. This phase usually starts at the end of the transitions. Now there are two main variety of two phase locking. One is strict two phase locking, other is rigorous two phase locking. So first we will be studying strict two phase locking. In strict two phase locking, a transition may release all the shared lock after the lock point has been reached, but it cannot release any of the exclusive lock until the transition commits or aborts. It ensures that if the data is being modified by the one transition, then the other transition cannot read it until it first commits. This solves the problem of dirty read, as well as this also solves the problem of cascading failure and recoverability. Second is rigorous. Rigorous is more strict as compared to the previous, that is strict two phase locking. In rigorous, a transition is not allowed to release any type of lock. Here we have only the exclusive lock, here any type of lock, whether shared or exclusive, until the transition commits. So a transition is not allowed to release any lock until the transition commits, whether shared or exclusive lock. This means until the transition commits, no other transition can acquire even a shared lock or a exclusive lock on the uncommitted transition. Now one more thing in two phase locking is that locks can be upgraded or locks can be downgraded. That is, a shared lock can be converted into a exclusive lock, that is known as upgradation of lock, or downgrading a lock means exclusive lock is being converted into a shared lock. Whole of this process is known as lock conversion. It can be used whenever necessary in our locking protocol, that is two phase locking. But this protocol is also not deadlock free. So to avoid this problem, we will be using another protocol that is known as time stamping protocol. Now this protocol used a timestamp. This protocol used a timestamp or a logical counter to be used as a timestamp. Every transition has a timestamp value associated with it, and the ordering is determining by the age of the transition. A transition T1, suppose created at 2 o'clock, would be older than all the transitions that come after it. See, if other transition come at 2:15, then that transition will be younger as compared to this transition T1. For example, any other transition T2 entering at 4 is 2 seconds younger than the transition T1, and priority is given to the older one. In addition, every data item is given the latest read timestamp value as well as the write timestamp value. This lets the system know when the last read and write operation was being made on the data item. This is the responsibility of the protocol that conflicting pair of the tasks should be executed according to the time stamping value of the transaction. The basic working principle of this protocol is that whenever an older transaction is too late in performing the desired operation, that is read operation or write operation, only two modes of operations are allowed. So, whenever the older transaction is too late in performing these operations, then the younger transactions will have the priority, and the older transactions that are too late in performing their desired operations, they will be rollbacked. Let us see how this protocol works. Now, the read timestamp of a transaction is TS, read timestamp of data item is denoted by RX, and write timestamp is denoted by WX. Let us see how this protocol works. Now, if a transaction Ti issued a read X operation, so whether that transaction should be allowed to read or not. See, if the transaction has a timestamp value that is smaller than write timestamp, the operation will be rejected. If the timestamp value is greater than or equal to the write timestamp value, then that will be allowed, because the transaction that is requesting is younger than the transaction that wrote the value of X, and that is a younger transaction want to read a value that has been already written by an older transaction. So, this operation is permitted. So, operation will be executed. Now, second is, if a transaction want to perform the write X operation, then if the timestamp of transaction is less than the write timestamp value, then operation will be naturally rejected, because that already a younger transaction has read that value. So, that operation will not be allowed. Second condition, if the timestamp value is less than the write timestamp value, then the operation is again rejected and it is rollbacked, case being of older transaction. Otherwise, the operation will be executed, that is the timestamp value is greater than or equal to the write timestamp value, that is the younger transaction want to update the value and we can allow that value. So, in a nutshell, we can say that a time stamping protocol resolves the conflict between different transactions by using the timestamp values. On the basis of that, we will be able to decide which transaction has to roll back and which transaction has not to roll back. So, whole of the concept has to be decided based only on the timestamp value. And a very important thing about this technique is that it is deadlock free, and hence it can be used in our system, so that we do not suffer the unnecessary problem of deadlock. Thank you everyone.